Sizeof yields the size in bytes of a type or of an expression. Two things about it that people get wrong. First, it is an operator, not a function. It is part of the grammar of the language, like plus or the ampersand. That is why the parentheses are only required when you give it a type name. Sizeof int on its own would not pass, so you write sizeof open paren int close paren. Give it an expression and the parentheses are optional, which is why sizeof x with no brackets on the fourth line is perfectly legal. Second, it is evaluated at compile time. The number is baked into the binary before your program ever runs. The one exception is a variable length array, whose size genuinely is not known until runtime, and that is the only case where sizeof produces actual instructions. And notice the print specifier again, %ZU, because sizeof produces a size_t. If you find yourself writing %d there, stop. It works by luck on some platforms and prints nonsense on others. Here is the single most common use of sizeof in real C. You have an array, and you want to know how many elements are in it. Sizeof R gives you the total size of the array in bytes for 20 ints at 4 bytes each, that is 80. Sizeof R subscript 0 gives you the size of one element, which is 4. Divide, and you get 20. Learn that as a unit, because you will write it hundreds of times, and because it survives editing, change the array to hold 30 elements. Or change its type from int to double, and the expression still gives the right answer with no maintenance. Many codebases wrap it in a macro called something like array_size or conf. But there is a trap in the small print, and it is important enough that the whole of chapter 11 builds up to it. This idiom breaks the moment the array is a function parameter. Because an array passed to a function is not an array anymore, it decays to a pointer to its first element, and sizeof then gives you the size of a pointer. 8 divided by 4 is 2. Silently, with no warning. And the last surprise. Sizeof does not evaluate its operand. It only needs to know the type of the expression, and the type can be worked out without running anything, so it does not run anything. Look at the second line. Sizeof of I++ gives you 4, the size of an int, and I is still 0 afterwards. The increment never happened. It was not optimized away. It was never part of the program in the first place, because the operand of sizeof is an unevaluated context. This matters whenever you put a function call or a side effect inside sizeof, which people do more often than you would expect in macros. A macro parameter used inside sizeof does not get evaluated, and if the caller passes something with a side effect, that side effect vanishes. The last two lines are the normal case and are completely fine. Sizeof int times n is just 4 times 5, a compile time constant multiplied by a runtime value. Again, the exception is variable length arrays, where the operand does get evaluated because the size depends on it. Rare, but the standard is explicit about it.